All right, everybody, it looks like we're at the top of the hour. I'm sure we still have a few more folks trickling in, but in the interest of time, I will go ahead and get us started. So welcome everybody to the 2020 Women in Clean Energy Conference. We are so excited to have everyone here with us today. For those of you that don't know me, I'm Katie Van Horn. I graduated from the University of Dayton in 2018 with my degree in mechanical engineering, and I now work with the distributed grid strategy team with ICF International in New York City. But the reason I'm standing here in front of you today is because I have had the unique opportunity to work with some amazing men and women to put this conference on over the past 2 years. It's no secret that women tend to be underrepresented across the energy field, and this conference was founded on the idea that we could get women to the table not only in the clean energy industry, but in the fight against climate change by providing the resources, knowledge, and connections necessary to build impactful careers in the clean energy field. So we encourage you all today to not only listen to our speakers, but to be curious, ask questions, and follow up. We invite all attendees to submit questions via the chat box throughout the session, and questions will be addressed at the conclusion of the event during the final panel session. We will also be providing contact information for all of our speakers as well for folks who have further questions after the sessions. As we move forward, please be aware that we will be recording today's session and the sessions will be posted online on our website. But other than that, I think that covers our logistics for the evening. And with that, I will toss it over to tonight's moderator, Brianna Dooley, who will introduce tonight's session. So take it away, Brianna.
Thanks, Katie. Good evening and welcome to the 2020 Women in Clean Energy Conference session on clean energy implementation and development. My name is Brianna Dooley and I am a fifth-year senior at the University of Dayton studying mechanical engineering and energy systems. I am part of the planning team for this conference and will serve as your moderator for tonight's event. In this session, women at the cutting edge of their field will discuss sustainable transportation, clean energy development, and other innovative technologies that are shaping the future of our planet. This session will give a broad look at the forefront of third-party clean energy development from the perspective of different industries within the field. Presenting first tonight is Emily Skill, Development Manager at Enel Green Power. Emily recently completed her master's degree in environment and society from the Utah State University, where she studied how municipalities develop, adapt, and execute 100% renewable electricity solutions. Emily has experience working with various solar and wind applications for Utah Office of Energy Development and Enel Green Power, Enel Renewable Energy. Emily now works as a development manager at Enel Green Power to bring large-scale solar and wind projects to the state of Illinois. It is my pleasure to introduce Emily Skill.
Okay, I think I'm unmuted now. Hello, everyone. Thank you for joining. My name is Emily Skill, and I am a development manager at Enel Green Power. I will start my presentation today talking about sort of how I got to my current role and where I am now and how I got here. So I am a graduate of the University of Dayton. I completed my Bachelor's of Science in Geology in 2017 and had a minor in Sustainability, Energy, and Environment, the C program. I also had a minor in Philosophy and completed a certificate in the Geographic Information Systems program. After graduating from the University of Dayton, I went ahead and attended the Utah State University master's program in Environment and Society, where, as Brianna mentioned, I worked with the Utah Department of Defense, or the Department of Defense, the Utah Office of Energy Development, and Utah State to develop a geographic information systems map to identify where across the state of Utah you can develop wind and solar projects that are compatible with military operations. Also in my time in graduate school, I worked on my master's thesis, which was studying how Salt Lake City, Moab, and Park City adopted resolutions to transition to 100% renewable electricity goals. During this time, I worked with city council members as well as sustainability staff to identify sort of how they built this community support and then what they're doing to implement those goals as well. From graduating Utah State, I started working for Enel Renewable Energy. I was able to sort of get my foot in the door with one of my committee members on my master's thesis at Utah State University. And at Enel Renewable Energy, I developed utility scale wind and solar projects. So Enel Renewable Energy is a renewable energy developer based in Salt Lake City, Utah. And in my time there, we worked across Utah, Wyoming, and Colorado to build wind and solar projects across those states. After working with Enel for about a year, I took an opportunity to become a development manager at Enel Green Power, doing similar work, but moving to the Illinois area to develop wind and solar in that region. So I'm currently calling in today from Salt Lake City, but I will be leaving here in just under 10 days to travel across the country and relocate to the Chicago area, where I will be working on the development outside of that region. So to give you a brief background on who Enel is actually originally an Italian company. It used to be a utility provider, but in 2008, they created Enel Green Power, which is a global company operating in 27 countries. Enel Green Power develops, owns, and operates renewable energy plants across the world. So in this map, you can see sort of where in the world is Enel, and what are those resources that they're developing. So as I mentioned, my focus is in North America and the Illinois region, working on solar and wind development. So today we don't have a lot of time, but I'm going to try to go through sort of what it looks like to develop a solar and wind energy project. Very high level, and I'm going to provide my information. So if you have more questions at the end, you can contact me. But for now, I'm hoping this will just kind of sum up, what it looks like when you want to develop a solar or wind project. So one of the first things to consider, and of course, I put these images on here to sort of kind of walk you through or kind of create a map of what it would look like to develop a solar or wind project. But of course, as many people know who do any sort of project management or development, sometimes these timelines are not linear. So I'll talk to them in a linear manner today, but understand that, things don't always go in that smooth of a process. So the first thing is sort of identifying where in the world you want to develop your solar or wind project. So there's many different sorts of siting criteria and characteristics that go into identifying what makes a site a good location for solar or wind development. So of course you have to think, well, where is there a good solar potential, or where is there a good wind energy? So those are some of the first things, the resource facts that you want to look at and sort of play into your computer systems here to identify, what makes a great location. Additionally, you're going to want to look at, what's the land look like out there, and is it close to other infrastructure like transmission lines or other substations and things like that that'll make your cost of developing your project lower. The closer you are to existing infrastructure, the cheaper it usually is or can be to develop that project. Some other things to keep in mind with siting is sort of, is this region somewhere where there's a lot of opposition to wind or solar? Is it going to be more difficult to work with the community in getting solar or wind developed there if there's already been sort of a negative experience in that area? Other things to think about are environmental factors. So is this, located in a forest or a wetland? These might be places you're going to want to avoid. Same with migratory bird paths, places where endangered species habitats are, are other things you're going to want to avoid when you're identifying, a prime site for wind or solar development. So many companies have different processes for doing this, as well as different ins and outs that help them identify what is an ideal location. But eventually you'll have a few different places that you look at and say, okay, this looks like a great spot. Let's move forward with this one. So once you find your spot and you're ready to move forward, the next thing you kind of need to look at is, okay, well, where am I going to get the land? So this is the next big step that I have here with these land for sale or land for rent signs. You're going to want to start engaging with landowners to see, is it possible to rent their land or purchase their land for this solar or wind project? Of course, it's going to be cheaper when you're just developing the project. You're not going to spend as much money on lease agreements at the development stages, but once that site is up and operating, you're going to be spending a lot more. So these are important points to make to your to the landowner, to these partners in these projects, and talk about sort of what are the benefits to them, as well as what is this project going to look like and what might the risks be. So sort of gaining support at a very local level and trying to gain partners in the project from the beginning. Without the land, you can't really do much else. So this next image, I don't know if you can tell, but it has like a little background on it. I had a very difficult time finding images of women when I typed into Google, women or just engineers graphics or surveyor graphics. A lot of them were of men. So I like to think that this conversation and this virtual conference we're having is really important, because there is a deficiency of women in the field. And so I think it's important that we're bringing this attention here today. So this image here is showing a surveyor. It can also kind of represent doing a variety of different surveys and studies on that land that we now have either rented or purchased or are in the process of negotiating some sort of agreement with. So, these types of surveys and studies can be anything from doing some basic environmental work, identifying if there's any contamination on the site, as well as identifying what the habitat of the area is, if there's any endangered species you need to avoid, or anything of that environmental nature, as well as identifying if there's any existing infrastructure on the ground. Is there a road that cuts through, or is there existing transmission lines? How about a railroad or underground piping? So, working with surveyors to kind of go out, see what's on that land first, so you can get these nice maps that identify this is what's on the land and this is what we need to avoid. These maps are very important with, sharing with the engineers as they design the projects and what they look like, and making sure there aren't any sort of issues later down the road. So this is a very proactive approach, and something that's definitely important when it comes to development of solar and wind. The next step I have here is these transmission lines. And as I mentioned earlier, when you're siting a project, you want to make sure your project is in close proximity to existing infrastructure. So these transmission lines is one of those important things you want to be close to. So this step here, it's very complex, but to simplify, you have to make sure you have an agreement with the utility in that region to allow your project, your solar or wind energy generating facility, to connect into their system. So this document takes a lot of time to get. It can take multiple years, and it's also very expensive process. The utility essentially has to do a variety of different studies to see what is your new energy facility going to, what sort of impact is it going to have on their existing infrastructure or their grid? Are you going to have to pay for some sorts of, network upgrades to their grid system in order to fit in the extra capacity that your project is going to be generating? And so this project, or this step in the project, is very important. But once you have this agreement with the utility, your project suddenly becomes, I would say, a lot more legitimate. Because if you're able to do, all these other things, but you can't connect your project into the grid, it's essentially not a project anymore. So this is a really huge step and something that's really important in moving forward with your wind energy development. The next thing is also really important. I tried to highlight, some of the most important things in wind energy development, but that's working with the communities that your solar or wind energy project is going to reside in. So maybe that's a county, or maybe that's a small town. Either way, you're going to have to build incredible relationships with these communities and with these local officials so that you can gain their support for the project. You will, if you're developing this project in a location that has already had solar or wind projects, they may already be familiar with, what to expect with this development. But in many cases, especially since solar and wind energy development is fairly new, some places don't know what to expect. So they know what solar or wind looks like, but they don't know what that actually means for their community. So they're going to want to learn from you on what those risks are, if there are any, and course, everything has a risk, of course. But you want to talk with them about the benefits as well and what can this project bring to their community. So those are some of the first things you want to talk about with those community members, but eventually you're going to need to work with them so that you can obtain a conditional use permit or special use permit so that you actually have permission from that legislative body, or sorry, from that municipality to develop in their community. So that's sort of that next image there, is obtaining those necessary permits. And then this bottom image on the bottom right, that's to kind of show you how all of this fits together in generating the design for your solar or wind project. So you've identified an ideal site, you have your land, you've completed your studies and your environmental surveys, you have obtained your agreement from the transmission or utility. You've worked with the community, you've gained your permits, and so now you have this site design that you're ready to move forward with. So then how does the project actually, get off the ground and get built? The next thing you need to do is can't go to my next slide here. Let's see. There we go. You need to work on finding someone to purchase the power. So we call this offtake. Oftentimes, especially when you're dealing with a commercial industrial customer such as Google or Amazon, you're going to see this in form of a power purchase agreement. So these are going to be companies, sometimes universities as well as cities, that are looking to buy power from renewable energy plants. And so that's what we're doing. We're working with communities, cities, companies, whomever, to find someone to buy this power. Once we have someone who buys the power, we can move forward with getting it actually built. But if there's no one there to buy the power, we don't have the demand to actually build the project. So I'm kind of putting this slide in here to show you how important and full circle it is when companies and universities and cities actually say, hey, we want to transition our power supply to be 100% renewable. These sorts of agreements and statements that these entities make is huge, and it's important for transitioning our grid to one that is powering with renewables. And this actually ties back into pretty well with some of the work I did in graduate school, working with Moab, Salt Lake City, and Park City. I studied how those cities are working together to transition to 100% renewable electricity. So that is something that sort of all kind of ties together here to get us from the developers to actually build these projects, as we have people who want to buy them. So then the next stop here is sort of just talking about, okay, so what does construction look like and how long are they operational for? So I'm just going to touch a little bit on these slides, or on this slide here. I work on the development side, not on the construction or operation, but I'm sure you all have questions about what this sort of looks like. So I'm just going to touch on here, and if you have more questions, let me know. But in terms of construction, solar projects can take 6 to 12 months. Of course, that depends on how large the facility is, and wind projects about a year to construct. During that period, you were going to be providing short-term but full-time jobs to community members. And so that is one great benefit of these projects. Another benefit that I didn't mention earlier that you would talk to your community about when you're trying to gain their support is that these projects pay a lot of money in property taxes. And so that property tax is usually around millions of dollars that is going back into those communities to fund their schools, to fund their libraries, to fund their fire departments, etc. And so it's really great because these projects are providing tax money without requiring, an additional 50 students at their schools each year. So they're not having any sort of taxing sort of requirement from those communities. It's really just saying, here's a bunch of money and our solar panels are going to go sit quietly over here. So those are some of the really great benefits of these projects. Again, jobs isn't always sometimes the best thing to mention, but they are jobs. They are there for a short amount of time. And during operation, there's usually a handful of people also working on site to make sure the projects are functioning and there's no technical issues. So operation usually parallels the length of a power purchase agreement, the PPAs we mentioned on the last slide. And so that's normally 15 years to 30 years, but I'd say the norm is around 20 to 25 years in length. And so after the project sort of reaches its, full term operation and the project has, finished, if the project were to receive another power purchase agreement, you can go through something called a repowering event, where the technology is replaced with the more up-to-date technology that we will have in 25 years or so, and the facility operates again. Of course, if you were renting land, you'd have to work with your landowners again to make sure you can still have that property and update any other permits that are needed. However, if the project, let's say, was not to run again for another period of time, it would be decommissioned completely. The land would be returned back to how it was before the project was ever built. So all of those turbines would be taken down, all the solar panels would be removed, and any other infrastructure would be removed so that the land is returned to how it was previously. And one really great thing that Enel is doing that I'm really proud of to be working with a company like this is that they're trying to create this kind of full circle loop where they're kind of closing the gap on waste. So we have a sustainability and innovation team that are working really hard to find repurposing and reuse for these materials at the end of their life cycle. And so that was my last slide here. And I think on the next slide, I just had a question or a moment for questions, but we're going to save that to the end. And I thank you all for your time and hope that was helpful to you.
All right, thank you so much, Emily. Our next presenter is Sandra Winkler, Senior Research Scientist of Research and Advanced Engineering at Ford Motor Company. Sandy's 30-year career at Ford has featured environmentally focused projects ranging from air quality to climate change, most recently with developing CO2 emission pathways for Ford's vehicles and manufacturing facilities. Sandy is also a member of the global Ford team that is developing the company's newly announced carbon neutrality goal. It is my pleasure to introduce Sandy Winkler.
Thanks, Brianna, and welcome everyone. I'm glad you're here. I am glad to be here and talking about how I've been involved in clean energy at Ford Motor Company. So I started my career at Ford about 30 years ago, as my introduction said, but before that I graduated from the University of Michigan Dearborn. My background is in mathematics and computer science. I got my bachelor's in math and very hands-on applied stuff, doing statistics and modeling things with computer science programs and computational mathematics, and took that a step further to go into my master's degree, working on operations research in the industrial and systems engineering program. Again, that's still a lot of modeling, optimization, linear programming, and really applying the mathematics to particular fields. With the math, there's the opportunity to apply it in anything, and the question just became, well, where am I going to apply it? And through a contact, I ended up at Ford, and that worked very well. But my first job was in, of all places, the chemistry department, where I worked at Ford Research Laboratory, as it was known then, now Ford Research and Advanced Engineering, and worked on air quality modeling. So this is studying the emissions from vehicles, facilities, not only just Ford facilities, but any type of facilities, and how they react in the atmosphere, the chemistry of those pollutants that come from the various sources, and how they're transported. And mainly we're looking at the formation of ozone. So that's an interesting pollutant. It's the major component of smog, but it's interesting because it's not directly emitted by anything. It's formed chemically. So the precursor emissions, the VOCs, volatile organic compounds, hydrocarbons, and oxides of nitrogen, or called NOx, that come from, of where we're particularly concerned with vehicles, but other places as well, are regulated. Those are called criteria pollutants. There are criteria set for how much emissions can be emitted from a car, how much can be in the atmosphere at any time. And so we have to meet those regulations, us as a company, Ford with our vehicles, and states and municipalities as regions have to meet the air quality standards. So to understand the very complex systems that all this chemistry and transport happens in requires computer models. So this was a very good opportunity for me to apply mathematics to do the modeling, describing all the equations for transport and advection, and learned a lot of chemistry along the way too. So this is really, kind of the first clean energy connection. Not so much as we'll be talking about, you heard already a lot about, greenhouse gases, and I'll talk some about greenhouse gas and climate change as well. But this is, air quality. This is what was happening, right around us. Big focus, this picture is on the eastern half of the US, but of course this study all was driven by, 50 years ago of the increasing smog problem in California. So some of the studies we're involved with, we're looking at different fuels, alternative fuels, and how those fuels react and produce tailpipe emissions, maybe more or less different types of hydrocarbons. Do those react differently? Some react more quickly, some more slowly. And so this was a different approach to understanding, is this fuel a source of cleaner energy in the criteria pollutant sense? So that was kind of the first exposure. The next phase of the process was, after we've been doing air quality for some time, as I said, I've been there for 30 years, climate change really started becoming more to the forefront, and Ford was very interested in that. And so I had an opportunity to get into the study of climate change. And so we began doing many studies and understanding what it means. And so I've focused on that mainly for the past 15 years. And as Brianna mentioned in the introduction, Ford has just made a commitment that we will be carbon neutral by 2050. And so we're focusing on three main areas that account for about 95% of Ford's carbon emissions. I'm involved in the some of the studies that do the calculations of how much the emissions come from different sources. And so of these 95%, there's vehicle use, our suppliers, and our factories. And just kind of think, I can't interact with you, but kind of think about which one you think is the biggest portion of those three. And I'll just give you a minute to think about that and see if you're right on the next slide. All right, so here's the pie chart. So the blue bar, or the blue semicircle, that's 75% of our emissions comes from vehicle use. Were you right? And only a small portion, this 3% here, actually comes from our factories. 17%, the dark blue, is from our suppliers. And then there's 5% that's other miscellaneous things. It could include business travel, transportation of parts to our factories and finished vehicles to dealerships. Lots of little things that add up to about 5%. So what you notice here is that we are a consumer of energy. We are consuming directly at our factories. That's, again, a small part, but we have emissions where we directly consume natural gas to heat and cool facilities, our factories, our offices. And then we also indirectly, we don't produce the electricity, but we consume a lot of electricity. And so those are indirect emissions. The other, the suppliers have similar sort of situation. They're manufacturing things for us, so they have direct consumption of fuel at their locations and purchased electricity as well. But again, this biggest piece is the vehicles that we sell. And what our customers are doing is putting fuel in them so that they can go places. And that is the majority of our emissions. Today, most of these emissions are fossil-based, so they're producing carbon dioxide, the major greenhouse gas, and we need to think about how we can take steps in the future to reduce that, that CO2 from our vehicles. So hence the clean energy requirement. We've been doing some things for a long time. And so with our factories in Cologne, Germany, we've actually had 100% electricity from renewable sources for more than 10 years now. And we are working, like Emily's mentioned, with a local energy supplier to provide that renewable energy. And we also have a plan to have here in southeastern Michigan, where I work in the Dearborn area, 2 of our major plants will be fully powered by renewable electricity provided by our local utility. And we have these, the purchase power agreements, the PPAs in place to make that renewable energy available to our facilities. Part of our goal is that when we are doing these renewable energy sourcing, it will be locally sourced. So again, companies like our local utilities, like Enel, those are what we are working with to get the renewable energy in place. Now to the side where I specialize in is our vehicles and clean energy there. So what we think about when we talk about vehicles is what we call a well-to-wheels perspective. That means we're thinking not only about the emissions, the CO2 that comes from the vehicle when we operate it, the combustion phase, or tank to wheel, but we also think about the well to tank emissions, or sometimes called upstream. So just walking through the steps, before you have a fuel that can be used by a vehicle, or energy that can be used by a vehicle, it has to be produced. So there's, either getting oil out of the ground, or could be natural gas or something like that. Or in the case of biofuels, you have to grow the biomass in some way. That raw energy has to be transported to somewhere where it can be refined, and there requires energy to refine it as well and get it into a usable form. And then there's energy required to get it to the retailing center, and then finally it gets to the vehicle and can be used. So each step along the way has greenhouse gas emissions associated with it. And you could put in this piece as well, electricity. So they're still, getting the fuel out of the electricity, fuel out of the ground to power the power plant, and then instead of moving it via trucks and things to get it to a retail station, it's going through those transmission lines to the wall outlet, and then you can charge your vehicle. So all of that produces emissions. And that, as I mentioned with the electricity, the piece to remember is that while an electric vehicle may not have tailpipe emissions, those emissions still are happening upstream here at the power plant. So we are trying to be comprehensive and get those, look at all those emissions. Another phase of things we look at is more of a life cycle assessment approach. And we talked about what we call the fuel cycle, what's happening with the fuels in the vehicle. But then we can talk about the vehicle production and disposal, or the vehicle cycle as well. So that's the raw materials to build the vehicles, the processing of those materials, building the vehicle, and then after its lifetime, the disposal of the product. And there's, again, CO2 emissions associated with all those steps that can be tracked. So a full life cycle assessment, it can differ. Right now, the vehicle cycle is about 20% of life cycle CO2 emissions, this vertical bar. And then the fuel emissions are about 80%. As we move more towards electrified vehicles using electricity, we'll see these emissions, and especially as we're moving towards clean electricity, that is from renewable sources, these well-to-wheel emissions will decrease, and these emissions will have a, relatively speaking, greater share of that percentage. So that becomes more attention to what is the production cycle and how can those emissions be reduced and become more effective or less polluting. The next graph I have is some examples of, this is a lot of information here, but it's an example of the well-to-wheel emissions and a study from a US Drive consortium. US Drive is a consortium between the vehicle manufacturers and the oil manufacturers organized through by the Department of Energy, so non-competitive work. And so just want to show you what the opportunity is on each side. The red line, so the black lines at the top of each of these fuel types is what the vehicle operating on that is current efficiency. The red line shows how much benefit you can get from improving vehicle efficiency. And then following the arrow bars down from the red line is how much more you can get by moving to renewable fuels. So in the case of an internal combustion gasoline or diesel engine, you see most of the benefit coming from the fuel. And but the takeaway is that this is really a system, and both things have to happen to get to these low carbon powertrain fuel electricity combos that will enable us to have a carbon neutral future. In fact, we see basically 4 pathways to carbon neutrality in a powertrain point of view, and they're all rooted in having a clean electric grid, low carbon electricity. That electricity can be directly used in a battery electric vehicle, or you can take it a step further and electrolyze water to produce hydrogen, which could be used in a fuel cell vehicle. The next step you could do would be to combine that hydrogen with CO2 captured from the air through a process called carbon capture, and then combine chemically the carbon from the CO2 and the hydrogen to make what are called e-fuels or electrofuels, and that synthesizes duplicates for gasoline or diesel, but they're all rooted in renewable electricity, so they don't have the fossil emissions. And then, or you could continue to use fossil electricity and just capture and sequester that carbon through this pathway and continue operating with internal combustion engines. So there's opportunities there. There's a lot of energy required as you move further to the right in this graph. The least amount of energy would be to just put that electricity directly in a BEV, of course, but there are then you have batteries to develop, and you have vehicles duty cycles that are subject to range. So a lot of opportunities, but how you optimize this, how these technologies come along to develop carbon capture and e-fuel are all things we think about and want to understand more about, and look forward to a clean future. I think that's all I have.
All right, thank you so much, Sandy. And last tonight, but certainly not least, we will hear from Reagan Mamer, Senior Manager of Innovation at IGS Energy. Reagan leads a team that specializes in energy product research and development on various fronts, most notably in renewable energy solutions, energy efficiency, and other behind-the-meter technologies. Reagan previously led the residential product team at IGS, where she brought a consumer-focused lens and data-driven approach to developing energy products. Reagan also has a relentless passion for achieving gender equity in the workplace and currently leads the IGS Women's Network. I had the honor of working for Reagan this summer at IGS, and it is again my pleasure to introduce Reagan Mamer.
Thanks, Brianna. Brianna is a powerhouse in her own right and was a pleasure to work with this summer. I'm so glad I had the opportunity to work with her. I'm really glad I have the opportunity to speak to you all tonight. I'm really excited about it. I'm going to talk a little bit about our IGS Labs team and what our focus is over the next 3 to 5 years, and then more specifically what we're working on this year. And so I'm going to give you guys a little bit of a behind the curtain view. First, IGS Energy, we're located in Dublin, Ohio, is our headquarters. We are the 3rd largest retail supplier in the country. And so what that means is, I'm sure if everyone on this call, you're probably familiar with the concept of deregulation, but just in case you're not, deregulation is when you have the opportunity to choose who supplies your electricity and natural gas. And so in a handful of states across the country, you're able to have that choice, and it's not just the default utility supplying your electricity and natural gas. And so that's what IGS does. We have both commercial and residential. So we have about 1.2 million customers across the Midwest region, and then in Texas and in California as well. And most recently with an acquisition in Georgia. So we're growing exponentially, and business is going great, but there wasn't an opportunity to have a dedicated team to focus on research and product development. So what the organization decided to do was assemble a team that had pretty general expertise across the entire energy landscape, and say, what could this team be? So this team could be someone who is able to intake new opportunities or discover new opportunities in the marketplace based upon their expertise in identifying consumer trends and identifying profitable business.
Everyone, we have a little bit of a technical hiccup, so just give us 1 second here.
Am I back? Can you guys hear me?
Yes.
Okay. Where did you last hear, Brianna?
I think it was, were you on fiscal year 19?
Yes. Yeah. I think I'll go ahead and just skip to the next slide. I think, Jen, you might need to give me control again. There we go. Okay, great. So as I mentioned, the purpose of IGS Labs is to grow and evolve our products. Our CEO, Scott White, has set some pretty ambitious growth goals over the next 10 years. And so as I mentioned, we're at about 1.2 million customers currently, and his goal is to have the equivalent of 10 million customers by 2030. And so how are we going to do that? Well, that's where Labs is going to come into play and help us think about where we can grow, how can we involve our products, and think about more of a national and international landscape. Some of the core competencies that our team has is, as I talked a little bit about, is product research. So understanding customer problems. You can have the best product in the world, but if it's not solving a customer problem, no one's going to buy it. So understanding the market trends, and then taking those insights and opportunities and conducting and talked a little bit about that. So we've done a ton of small scale pilots, working on internal handoff integration, and again, how to solve consumer problems. On the business development side, so this is a newer one as well, and we have a team member who's leading this, is identifying new affinity relationships that can potentially sell our products as well. And so, as I mentioned, getting customers is, we've typically been a direct to consumer brand. And so we are looking at expanding that to say, what would this look like from an affinity perspective? And then energy technology expertise. So a ton of tech scouting, understanding energy insights, and then understanding the regulatory landscape as well. So when we think about opportunities at IGS Labs, one of the things that we consider is when we think about our focus areas over the next 3 to 5 years, where do we want to be spending our time? And so these 5 main themes emerged for we should be butting up any opportunity that comes our way against these themes. If it doesn't fit, it's maybe not worth our time. So energy efficiency, so monitoring and insights. A lot of our commercial customers have a desire and a cost incentive to understand and make reductions in how they consume their energy. And so we're in a position to be able to help them do that. We want to provide the best product that's able to help them do that. Carbon emission reduction. So I think that that's been a theme across the night. IGS Energy has set a very ambitious goal to be carbon neutral by 2040. And so when you talk about a natural gas supplier and an electricity supplier being carbon neutral, that's a really aggressive goal and one that I'm really proud of that we're setting. And so we're really thinking through some of these tactical ways to reduce carbon emissions. Electrification, so this went really well with our previous speaker, Sandy's presentation. So obviously, if there is going to be the surge of electric vehicle adoption, how are those customers going to be charging their electrical vehicles? With electricity. And so that's going to be a surge on the grid. And so what our team is thinking about is how do we design electricity rates for consumers so that they're able to use and charge their vehicles in off-peak times and really start to incentivize them to do that so that the grid doesn't become overwhelmed in 10 to 20 years. And then we mentioned a little bit behind the meter technology. So think battery storage, and then renewable energy solutions. So we already have a solar, residential and commercial solar business. However, those businesses are focused on the financing portion. And so we are trying to think creatively around how do we kind of own that soup to nuts sales development cycle and not relying on third-party partners for sales generation. This is just to show that the purpose of our team is to be really nimble, really lean, learn really quickly, and then if we fail fast, that's actually a good thing because that means we're not wasting a ton of money. And then if things go well, then that's great too because we're able to do it in a really small, confined way and then implement it into our organization if it makes sense. So we're kind of separate from the larger corporate organization, which means we have a lot of flexibility and a lot of free reign, which is great. So I talked a little bit about 3 to 5 years, but when we think about the next year, these are on our list of opportunities that we'll be looking at. And so I'm going to run through these super fast. If you have any specific interest in anything that I'm going to talk about a little bit here in a little bit, please feel free to reach out. I am going to fly through these just in the interest of time. So I talked a little bit about this, but commercial energy insights. So across the country, there are a lot of cities and a lot of certain metropolitan areas who are saying, I need every single commercial customer to benchmark their energy. So I need to know how much gas you're using, how much electricity you're using, how much water you're using, and those benchmarking solutions are shown to reduce commercial customers' energy by about 2 to 5% annually. And so what IGS is trying to get in front of is how do we put a consumer's interval data into a really consumable, digestible, actionable way for them. And so that's something that we're really excited about, is to be able to start to intake all of this data from a customer and say, here's the things that you should be thinking about, and here's the things that you should be doing in order to reduce your costs, not only for a cost benefit, but for a earth benefit as well. So many companies, I'm sure, as we've all heard, have these aggressive carbon neutrality goals. And so IGS is in a really good position to provide products and solutions that customers can use to offset or reduce their own usage. As I mentioned, we had a pretty lax product development process, and so that's one thing that we're fine-tuning over the next year. We at IGS were typically inside out, so we would say, someone in the company has such a good idea, and then we would develop the entire product and then talk to a customer. Whereas we're taking an outside-in approach where we say, let's start with the customer, learn from them, and then identify opportunities based upon that customer, and then start building. And so one of the things that we've tried to do is, in order to scale, you need to have a really well thought out and documented process so that anyone can pick up this process and run through it themselves. And so innovation doesn't just happen within innovation. And so we're trying to educate the rest of the company ways to test ideas in a really clean and simple, efficient way. And that's one thing that we're focused on over the next year, is fine-tuning ours. And then having these defined outputs is really important, because as you're talking with the business, you want to make sure that they're on the same page as you through every stage of the product development process. So if I'm working on commercial energy insights and we're bringing the commercial sales team along, I want to make sure that they're digesting and they're able to understand everything that we're working on. So when you have a consistent view that you're constantly showing to your business partners, that really helps. One opportunity that I'm particularly excited about is this concept that we're calling neutral. So one thing that we learned when we talked to consumers was that they really want to make a positive impact on the planet. They're doing, a ton of great things already. They're recycling, they're using reusable grocery bags, but they're like, is that enough? Is what I'm doing making a difference? And so this idea of neutral is born, where a person is able to calculate their personal carbon footprint and then choose a carbon offset project that they want to offset their footprint with. And then it would be like a monthly subscription to eliminate your personal carbon footprint. So it's a pretty cool concept that we are currently working on and plan to start piloting in the spring. So this is one that I'm really excited about. Here's just a little bit of a customer flow of how that might work. So again, this product, the real value here is we are limited by deregulation. And so our current footprint is, I believe, I don't want to butcher this, but I believe it's about 14 states. And so this type of product allows us, excuse me, to open up to an entire national and even global footprint. And so that's something that we haven't been able to crack the nut on just yet. But we think this product could be our first step into a national or global play. Backup generators. So not the friendliest clean energy approach. However, as I'm sure you guys are seeing out in California, customers who don't have power for days or weeks because of climate change. And so a backup generator, while not necessarily the cleanest way to power your home, is often one of the only ways to power your home. And so even in the light of COVID, we've actually seen an incredible uptick of interest in backup generators. And one thing that we would do to make this a carbon neutral product is anytime your backup generator is running, we would be providing carbon offsets for you. And so this is something that we're still kicking around, and we're not 100% sure that we want to go to market with this, but it is an interesting opportunity, especially because our partner Generac has a Wi-Fi enabled alternative rate design. So as I was talking a little bit about with the electrification strategy, this would be, and right now a lot of our plans are what we call fixed pricing. So dependent upon how many therms or CCFs that a customer uses, or kWh, a customer is billed a per kilowatt hour rate. And so what we're exploring is what we call time of use, which would actually incentivize a customer to use energy at a specific time. And so when we talk about those electric vehicles, we would want to be incentivizing customers to use their energy at those off-peak times. And so time of use is becoming a more and more common term in the energy industry. And with the adoption of smart meters, it's actually able to come to fruition now. And so this is something that we'll be working on over the next year as we think about our electrification strategy. International expansion. So I touched on this a little bit, but if we want to grow to 10 million RCEs by 2030 and introduce more clean energy products into the real world or into the rest of the world, and I think I forgot to mention, but all of the residential products that IGS sells, so any product that a homeowner would buy, is clean. And so we actually only sell carbon neutral gas and green electricity. And so as the third largest energy supplier, that was a big, bold move for us, and one that we're really proud of. And so if we're able to take that approach to the rest of the market internationally, we think that with our expertise and success here in the States would hopefully translate. However, as I said, there's a lot of potential out in the international deregulated energy world. And so it's one that our team is helping to identify and helping to narrow down. So over the next year, our goal is to really just start educating our executive team on the different opportunities that exist within the deregulated international market and where might be a really good fit for us to start. I already talked a little bit about electrification, so I won't get too much into it, but really this electrification strategy goes hand in hand with that alternative rate design. So what we picture is almost a rate plan that matches your lifestyle packaged with some sort of EV charger. And so we might partner with someone, and that would lead me to my next one, is this Affinity partnership. So we might partner with someone who's already selling the EV charger hardware, and we might put our rate on it and then sell that as a package. So that could be an example of a product that labs would come out with. And so Affinity partners, we think, is a really great and valid way for us to continue to grow our customer base. These are just some examples of what an Affinity partnership could look like. So IGS and a partner can sell or promote together. IGS can sell or promote through a partner, and a partner could sell through us. So we could white label someone's product and sell that. Okay, that's all I had. I don't know how I was doing on time, so hopefully okay.
Yeah, thank you so much, Reagan. And thank you to all of our speakers tonight for providing insight on the latest and greatest in the clean energy field. I would now like to invite all of our speakers back on video for the Q&A portion of this session before we end this evening. Again, please enter your questions in the chat or in the Q&A section. So the first question I have, I believe, is for Emily. What are some of the factors utilities look at during the interconnection process?
That's a good question. So from the developer side, sort of what I would provide to our engineers that are interfacing with the interconnection utility and companies is they want to make sure we have the site control so that we can actually put the facility on some ground. So based on the number of megawatts you're trying to build out with your solar or wind project, you need to have X amount of land. So like a rule of thumb for solar is usually 5 to 7 acres per megawatt. So that's one thing that they're going to look at. Some utilities aren't going to be as strict as to how much land you have. They just want to see you have some land already, leased, or, some sort of option agreement to purchase or some form of negotiation. Sometimes the utility can say you can pay an extra $10,000 and not have any site control at the moment, but as we move more forward along in this process, we will eventually need to see at this stage that you do have that site control. So that's one thing. Another thing, I know I'm just going to make this short because we only have half an hour for questions, but another important factor is understanding when you want your project to come online. So we call that the COD, that's the commercial operation date. And so the utility is going to need to know, when is that commercial operation date going to be, or when do you want it to be? And at what voltage are you trying to connect into either their substation, or what transmission line are you trying to tap into to connect your system to? So those are maybe the main two things that those interconnection utilities or interconnection processes require. There's a lot of other things that our engineers actually need to provide to them, such as, very specifics on the types of, technology we're going to be using throughout the site. But again, at the very beginning, initial stages, they only need a little bit of information. But as we get further along and are starting to execute that agreement, they're going to need to have a lot more things finalized and know exactly what sorts of inverters and panels or wind turbine you're going to be using for the project.
Thank you. And while we're on that topic, there are a couple more for you. I'm going to kind of be shuffling these questions, but next question is, how often are you doing virtual PPAs versus a local off-taker?
So I would say it's a good mix. It's a little bit difficult too to answer this question because I've only begun working for Enel just 3 weeks ago. So I was at a different company. I mentioned Enel Renewable Energy for about 15 months. And now that I'm with Enel, my role with Enel is very much focused on the development. I don't, I don't really engage oftentimes with those individuals that are working to purchase the power. So we have a whole team that's designated to that. But when I was with Enyo, I was more involved in those discussions, and it's a good mix of both. And it seems to be that way with Enel as well. Sometimes it's this little bit of a dance that you play where you have the utility that just sort of collecting all that power, and you have this agreement from our developer to the utility, and then the utility has an agreement with let's just say Google, and then Google also has an agreement with the developer. And so Google is not getting the energy from our plant directly. They're sort of buying it from the utility per se, but they're paying us for it too. So it's this really interesting, very intricate sort of triangle of multiple agreements to sort of arrange how the power is actually going to get to them. And that's sort of the interesting thing too, and sort of mentioned in virtual power purchase agreements, is you have electrons getting there somehow, but they may not actually be the renewable ones, but they're paying to have those renewable ones on the grid to help sort of diversify that portfolio and get clean energy on the system.
Thank you. The next question I have is for Sandy. To what extent did you seek out a role in clean energy? And do you have any advice for those in industries outside of energy and how to incorporate clean energy into their role?
No, I did not seek out a role in clean energy. As I mentioned, I was a math person, and I just wanted something to apply to it. And that's just sort of the envelope that came along, and it ended up being a good fit. I mean, I always recycled and was interested in the environment, but that wasn't my plan. It just was a way up. For those who don't work in energy but want to think about including energy in clean energy in whether it's your daily life or your job, that's a really good question. I would say, just think about, in your daily life, if you just can choose to walk instead of drive, that it's not really substituting clean energy, but it's displacing it. There's choices you can make. So Emily and Reagan, I think, talked a little bit about time of use. There's also, you can look up, when the CO2 emissions are highest during, from your provider. So you could choose to operate, not only when it's cheapest, but when the CO2, if it's a coal plant that's on the margin, that's going to turn on to meet air conditioning demand or something in the late afternoon in the summer, then you maybe don't run your dishwasher and your washing machine at the same time. You save that to do it when the demand is down and you're using the base rate, which could be natural gas or coal. So those are common examples. I'm not the electricity provider, I'm a vehicle person, but correct me if I'm wrong, Emily and Reagan. So those are a
I would
couple
just say,
suggestions.
build off that. You could put a case together for your own company sourcing green energy. And so not only you personally can source green energy for your home is actually about 25% of your carbon footprint, which is a lot. And so that really small, simple move can drastically reduce your personal carbon footprint. And so the same with your corporation. So if your company isn't sourcing green power, you could be the advocate that speaks up and says, hey, I'm going to put a business case together for our company to switch to green power or carbon neutral gas. And so that could be a really simple way to start to incorporate it.
Yeah, I was going to build on that too. So as I mentioned, my master's thesis work studied how 3 cities in Utah were the first cities to adopt goals for 100% renewable electricity. In 2 of those cities, those goals were driven by very committed community members. And so from my master's work, I created this framework to help community members or even staff that work within the city to sort of build that public support to adopt those sorts of resolutions to help make your city a cleaner city, and therefore the energy that you receive at your home cleaner as well. So if you're interested in that, I had the picture on my one of my slides of what that framework looks like, but I can send that out so you all can get that as well. And that's another great way, just getting involved within your local politics and speaking up at city council meetings or county commission meetings is another really great way to show that you're interested in clean energy and you're willing to support it.
Thank you, everyone. The next question is for Reagan. What are some of the inputs that you would put into a calculation to determine your personal carbon footprint? So you just touched on this a little bit, but how do you make this consumer friendly?
So I think we all know what experiences we've had in the past that are really simple and easy, and we leave and we're like, wow, that was amazing. I love that brand. I love that company. And so that's what we want to do, is we want to make it really simple and digestible. So it would start with a lifestyle quiz. You would answer how often you fly, how often you drive, or do you drive to work? Do you take the bus? Do you bike? What is your diet like? Are you vegetarian? Are you a meat eater? And so all these little things that go into making what your personal carbon footprint would be, but bubbling them up into specific categories to make it really simple for a customer to run through it. And it's also a really approachable price point for a customer to offset their carbon footprint, which is typically a surprise to them because they think that it's a lot more than it actually is.
Thank you. And the next question is kind of for all 3 of the speakers, but the question is, what is the biggest challenge you have had to overcome working in the energy field?
I can go first. It's no surprise that the energy field is a male-dominated field.
Emily or Sandy, do you want to fill in for a minute?
I can fill in. I think we're probably going to say similar things, especially in Utah, where I had my first career as a woman. Well, I am a woman, but having my first career in Utah, being in the field where it's predominantly a man's field as well as an older generation's field has been really interesting. I think if she's about to hop back on, Reagan, you can go back, keep talking.
Oh, I'm just going to be done. This is so annoying. I'm so sorry, you guys. I was just going to say, getting men as part of the conversation has been a really big piece of the work that I've tried to incorporate into the IGS Women's Network, because we can all sit in a room and
Go ahead, Sandy.
Okay. Yeah, I don't know that I would say it's an obstacle to work in a male-dominated field. It's definitely true. On the bright side, when you have a big, director-wide meeting, the lines to the bathroom are a lot shorter. So for the women, that's a kind of a plus. But I think it's not, again, not an obstacle, but there's just things to think about a little differently, and your perspective is not necessarily what it comes from. And, Emily started to touch on different age levels too, and that might be a different perspective. But I think that happens regardless. I'm kind of the senior person now, but when I started, there were the older people who were looking at things differently too. So. Again, not an obstacle, but just a difference to be aware of.
Yeah, I was just going to build on that and say it made it a challenge at first to sort of be taken seriously. Being young and being a woman, especially in Utah, Utah is very different. I grew up in Ohio, went to school in Ohio, and it just does have a different culture. And so that was something to get used to in the work field. But I would say my actual biggest obstacle has been when I'm trying to communicate to sometimes communities and people who are hesitant or resistant to solar or wind projects. A lot of them are hesitant due to misinformation. And so a lot of what I've had to sort of learn and change my style of, sort of talking with people is definitely changing it to sort of more educational, where and providing additional sources for people to learn about what is solar and wind, because there are some incredible miscommunication about what solar and wind is that have created some sorts of fear or intense opposition in some areas of the country. And so that was something that was kind of surprising to hear, especially because I've always kind of been interested in renewables since college, and I've really only ever heard one side of things. And then working now in a very different kind of climate and culture, I'm hearing a lot more concerns. And so being open to those concerns, taking them in and responding with, pure answers based on facts and where they can learn more, to sort of put those fears aside and realize that those aren't based on science.
Thank you all so much for your answers. The next question is also for all speakers, but we have a couple questions revolving around what experiences can young women or undergraduate students do to jumpstart their career in clean energy? And then what experiences were helpful for you when trying to decide which path to pursue in clean energy?
Well, I am a huge advocate for co-ops and internships. I think that is absolutely an opportunity you should not pass up if you have a chance to do that while you're an undergraduate. It can help in so many ways. It makes contacts, it makes future opportunities, it puts something on your resume. And it might also tell you that you really don't like the area you thought you were interested in when you really get right down to it. Hopefully that's not the case, but that's a value as well. So I think those are opportunities you can take of. And then the other thing would be to attend seminars and webinars and meet people and develop, maybe not, it could be turned into a mentoring relationship, but even do informational interviews and find out more after you've initiated those contacts to start with.
I can second that. Unless I was Reagan. Reagan, did you call in? Did you want to speak first?
No, you can go ahead. I'll speak after you.
Okay. So I would also second internships. I did an internship almost every summer between each year of college, and then continued to do an internship in my summer in graduate school, which made things really busy, but it was a really great experience. So I would say internships are incredibly important. Start to network with people like us. Attending events like this is also really great. So you're already doing the first step there and getting involved. Continue to come to events like this. Follow up with us after. I am not sure about, I saw a question on there about internship opportunities. I'm not sure, if Enel is looking to hire for internship opportunities, but it's never wrong to ask. And so I can also inquire about that as well. We do need to continue to train younger people in college, high school students even, to gain these tools early on in their life, so that we have a new set of people out here doing what we're doing as well. So keep networking, attend conferences. I went to a lot of conferences in graduate school. Wish I went to some in undergrad. So I would talk to your advisors about opportunities to attend conferences as well in person. Of course, due to COVID, that's a bit difficult, but perhaps next year, if you're only a freshman or sophomore, that might be a really good opportunity, even if you're not going to be presenting, to at least attend to sort of network with people who are, new in the field, as well as really, experts in the field.
This is Reagan. Sorry, I'm calling in, so I can't see you all. But I think the biggest thing for me is I actually didn't have a ton of energy expertise. I was a finance major. Most of my internships were finance related, and I just kind of landed at IGS because it's a wonderful place to work. However, once I got there, I started to really see the value that our products could provide if we were selling 100% clean products. And so I showed a natural affinity to help an organization move in that direction. And I wasn't quiet about it. I was pretty vocal about it. And so don't be afraid to, if you see an opportunity within your organization, don't be afraid to make a case or throw out an idea, but make sure you have some facts behind it. Make sure you have a business case to support it, because people will pay attention, and people really like it when people are enthused about the work that they're doing and excited about the work that they're doing. One thing that I would say is, on top of the internships, not only do internships across different fields or industries within clean energy, but do them at different companies. And so, a company might treat their solar division completely different. One might be a financing arm, one might be a development arm. And so there's a lot of different ways that you can get involved in the clean energy sector. I think that internships are the best way to start, and to start to get your feet wet into which area or industry you want to work in, but at which company as well. And so, Enel and Ford and IGS Energy are all three very different companies, but we all have clean energy in common. And so you can see the wide variety that starts to exist there. Talk to people, like Emily said, about us, and start to talk about what interests you within clean energy, and we can help to point you in the right direction of where those interests may lead to a career.
Thank you all again. The next question looks like it is for Sandy. There's two that kind of go with this, but Sandy, is there a carbon goal at Ford related just to carbon emissions produced by the cars they produce? For example, all cars are electric or carbon neutral by 2050. And then supplement to that is, do you think Ford will reach their carbon neutrality goal before 2050?
Let me take the second one first. We think parts of the business will be carbon neutral prior to 2050, especially in areas that are more proactive. We think Europe is on a track to being carbon neutral earlier. The European Union has a goal of 2050, so we think new vehicle sales would need to be carbon neutral by 2040 or so, to make sure that the whole fleet rolls over and becomes carbon neutral on the road by 2050. Then we would also look at California leading the way. Governor Newsom just announced a ban on new vehicle, internal combustion vehicles by 2035 in California. So those are areas where we would see carbon neutrality, and the vehicles we sell there meeting those requirements, and setting the stage for the development in other areas. So as a company, it depends. Our goal, we think realistically, is for the whole company to be carbon neutral by 2050, but in areas we hope to achieve it earlier. So do we have a goal specifically around vehicles? Again, in different regions, we would see it happening sooner than later, and we would then be reaching out to make that, right now, I think the biggest lever we have towards carbon neutrality are battery electric vehicles. But you could equally, again, that would require that the grid is progressing as towards carbon neutrality as well, because you have to power those vehicles with clean electricity to be truly carbon neutral. You could also, as I showed in that pathway, you could develop clean hydrogen to power vehicles. So fuel cells would be another option other than battery electric vehicles. So those are some of the pathways we see that are feasible now. Longer term, it might be some of those other pathways where we talk about that, we could still continue to sell internal combustion engines. It was just that the fuels would either have to be made differently through an e-fuel pathway, or there'd be a method, a reliable method and scale to capture and sequester the carbon that is burned or created when fossil fuels are burned. So a couple different, it might not be an all battery electric vehicle solution, but in the near term, that would be the solution.
Sandy, you might be able to add on a little bit to this too, but another question in a similar manner is, you mentioned that BEVs would be the cleanest energy option, but is battery manufacturing as clean as we hoped, or is there still a lot of development and research going into that?
Yeah, the batteries are definitely under a lot of scrutiny, and it's of interest. There's a lot of elements to building a battery, just like there's a lot of elements to all the materials that go into the cars. So that is on our radar, and we'll be researching it internally and relying on external understanding of what that's involved. I think the end of life is a big question, so we have research going on into second life for mobile batteries. Could they be reused in a stationary manner? So there's yeah, it's definitely a systems, and we have to consider all those elements. Don't know exactly what that solution is, but we're looking into it like many other people are, and many other research institutions and governments and so forth.
All right, thank you so much. I think that is our last question this evening, just in the interest of time, but thank you all so much for your great questions for our speakers. And now I will hand it back over to Katie Van Horn.
Awesome. Thank you, Brianna, and thank you to all of our presenters here today. So thank you again also to all of our attendees as well. At the conclusion of the session, you will be taken to a survey. If you would please fill that out, that would help us out greatly for future sessions and future events we're hoping to host in addition to the conference. In addition to the survey, we will also be sending out presentations, as well as posting the actual recordings on the website. We will also be following up with speaker contact information, so you will receive contact information for all of the speakers here today, as well as the speakers who are speaking at the sessions occurring after this, including clean energy regulation and policy, social impact of clean energy, the keynote, Susan Brennan, as well as the postgrads panel session. And then finally, we will be sending out lists of open positions from recruiting companies. Some of those companies include my company, ICF. So we will be recruiting, and you can look for those emails coming in the coming days. Thank you again, everybody, and have a great evening.